Okay, welcome to section 11.2. We are going to be performing radical operations. Now, if you remember the little Ninja Turtle video, radical. All right, that's what we're working with today. So when we start off here, we're going to be, like I said, adding and subtracting. We're also going to multiply and look at what division means as well. But when we add and subtract, we need, hold on a sec, we need like radicands. Remember, that's the number under the square root sign. And then we just want to add or subtract the, I'm going to call them coefficients, because that's what they act as. Like when we were combining like terms in polynomials, okay, we're doing the same kind of thing here, but instead of having variables after the coefficients, we have square root signs. So it gets pretty easy here. 5 plus 7, sorry, 5 plus 7 is 12. And so we have 12 square roots of 2, okay? And so that just comes from, here we have 5 square roots of 2, here we have 7 square roots of 2. When you add those together, you get 12 of them, okay? The next one here is, we have like radicands, we have 7s, so square roots of 7. And 12 minus 9, 21 minus 9, I keep giving away the answer, is going to be 12 square roots of 7. Okay? Now sometimes we'll be forced to simplify a radical before we add or subtract it. Okay? So right now there's nothing I could do because I don't have like radicands. I have 3 there and 48 there. But let's look at simplifying 48. I know that that's 8 times 6. Now 8 would be 4 and 2, and 4 would be 2 and 2, and 6 is 2 and 3. Okay, so I have exit buddies. If you remember my conversation about Crush, the turtle from Finding Nemo, having an exit buddy. All right, that's what we're looking for here. Our exit buddies to get out of that square root sign. So what I'm left with is 5 square roots of 3 minus, I have 2 groups of 2, so that is 2 times 2, which is 4. So I have 4 square roots of 3 there. And 5 square roots of 3 minus 4 square roots of 3 would be 1 square root of 3 that we can just write as square root 3. All right, not too bad, huh? Kind of fun, actually, because we found something that relates to other things that we've done. Okay? These next ones are looking a little bit more tough, this next row here, because there is a lot of simplifying that we have to do before we can even think about adding or subtracting. 54 splits up into 9 and 6. 9 is 3 and 3, and 6 is 3 and 2. All right, the 9 is a perfect square. It has 2 exit buddies of 3. So that's going to be the same thing as 3 square root 3 times 2, which is 6. The square root of 5 is fine, so we have 2 root 5. And then we're going to have minus, now 500, oh boy. That splits up into 5 and 100. Well, 100 is a perfect square. It's 10 times 10. I don't have to break that down any farther because the 10 has an exit buddy. All right, so I didn't have to write that as 2 and 5 and 2 and 5 and then multiply those back together to give me 10. I could just make that jump right away. And so we have 10 square roots of 5 there. I have like radicands here, kind of like, like I said before, it's kind of like terms. In fact, it's the same process. But that 3 root 6 is just going to be by itself. And then I have a plus 2 and a minus 10. That's going to give me minus 8 square roots of 5. And that's my final answer. Okay. Let's look at the next one. Let's see, 63 is kind of ugly. That would split up into 7 and 9. And 9 is 3 and 3. So we have 3 as an exit buddy. All right, we're multiplying that by that negative 3 there. Gives me a negative 9 square root of 7. 175. That looks like if you divided 5 It's kind of hard to see, but that's a 5. And then 35, you could then split it up into 5 and 7. 5 has an exit buddy, so that's plus 5 square roots of 7. And then 169, if you remember from yesterday, or last section, that's a perfect square itself. You could even punch that in on a calculator, and it's going to tell you negative 13, or minus 13. But we do have like radicands here and here. That's a negative 9 and a positive 5. Gives me negative 4 square roots of 7 minus 13. Final answer. Yes, sir. Okay, let's look at this one here. I'm kind of stumped here. I have 338 under a square root sign. I know it's even though, so it's a multiple of 2. And when you go 338 divided by 2, you get 169. And 169 we talked about on the last problem has 13 and 13 as its factors. So the 13 has its exit buddy. So we get 13 root 2. 18 splits up into 2 and 9. And 9 is 3 and 3. So 3 has an exit buddy. So that's going to be 3 root 2. And then 50 splits up into 2 and 25. 25 is 5 and 5. 5 has an exit buddy, so we get minus 5 root 2. All right, all three of these have like radicands, so we're going to be left with just one term in the next step. 13 plus 3 is 16, minus 5 is 11. 11 square roots of 2. And that's my final answer. All right, I want you to go ahead and pause the video and try the next 3. Okay, welcome back. Hopefully you had a chance to get those done. Square root of 15 is that's as simple as it can be. But if I split this up, 60, I know it splits up into 2 and 30. 30 splits up into 2 and 15. And I know that 15 is at its simplest form, but I can go ahead and split that up even farther into 3 and 5. 2 has an exit buddy. So we're left with square root of 15 plus 2 root 15. 1 square root of 15 and 2 square roots of 15 gives me 3 root 15. Okay. Moving on to the next one, we have 5 square root 32 and 7 square roots of 2. Well, 32 would split up into 8 and 4. 4 splits up into 2 and 2. 8 splits up into 2 and 4. And 4 splits up into 2 and 2 as well. So I have 2 exit buddies of 2, which means I have 4 square roots of 2. And we're going to take that 4 and multiply it by that 5, so we get 20 root 2 minus 7 root 2. Giving us a grand total of 13 square roots of 2. The next one's kind of difficult, but in the interest of time, I'm going to go ahead and write just the next step. The 252 simplifies to 6 root 7, and then we have minus 4 root 7, and plus the 8 root 7 that's there. That's an ugly, ugly 7. But there we go. All right, and simplifying that out, you have 6 minus 4 plus 8 would be 10 square roots of 7. And there we go. Okay, let's look at the next section. Here we're going to be multiplying radicals. Now, we kind of talked about this in the last section, but we did it sort of the opposite way, that if you have 2 square roots, you can multiply them by each other. So like square root of A times square root of B would be the same thing as square root of A times B. Okay? And we're going to be using that fact today throughout these problems of multiplying. But the idea, or the big idea, is that what you really want to do is multiply numbers by numbers and radicals by radicals. Okay. So multiply numbers by numbers and radicals by radicals. And then we can simplify if we have to at the end. Let's look at the first one. So out in front I have a 3 and I have a 1. 3 times 1 is 3. Square root of 2 times square root of 3 is 2 times 3, which would simplify to 3 square roots of 6. No simplifying that can happen with the 6, so we're good to go. On the next one, I just have square roots. I don't have anything in front. So that's square root of 5 times 15. Okay, 5 times 15 would be 75. So we have square root of 75. Now that can split up into 3 and 25, and 25 would split up into 5 and 5. So I have an exit buddy there. This is the simplifying part of multiplying radicals. Okay, once you multiply them together, you try to split them back up and make it a little bit easier. Okay, so let's look here. 5 times 5, so that's going to be 5 root 3. Okay. I want to look at a little easier way to do these problems, because there's always, or most of the time, one little bit easier way. Out in front I have 4 times 1, which is 4. And then I have square root of 6 times 3. What you can do, instead of multiplying this up, if you have any composite numbers, meaning that you can find 2 factors or more factors, you can split it up. I know 6 splits up into 2 and 3, so I could rewrite that as 4 square root 2 times 3 times 3. So you see how I kind of skipped a step, sort of. You know, I don't have to now split the number up. I've already split it up. 3 has an exit buddy, so we get 4 times 3 root 2, which is 12 root 2. All right. So that's kind of the basic multiplying, basic idea of multiplying radicals. On the problems below, there's an added little feature. We have parentheses now. Goody goody. You know what parentheses mean, though. We want to distribute. So I have, this turns into 4 root 6, and then plus square root of 6 times square root of 6, which is the same as 6 times 6. And 6 has an exit buddy. And even if you multiply that out, you get square root of 36, which is a perfect square. So we get 4 root 6 plus 6. Pretty neat, pretty nice when problems work out for you. And here we go again. We're just going to distribute. So when I distribute this, I'm going to get 2 square root of 6 times 3 plus square root of 2 times 3. Okay. 6 again splits up into 2 and 3. So 3 would have an exit buddy. So 3 comes out. 3 times 2 is 6. And we're left with a square root of 2 on the inside. And then plus square root of 2 times 3, which is square root of 6. No simplifying done on that last part. Okay. I'm trying to see what I can do to lessen your work. And, you know, I know you guys don't like to write out all the steps, which is okay on some things, but not on others. On this part, it's okay to do that. Okay. Let's go ahead and move on to the last one here. So we just want to distribute this inside again. So we get square root of 5 times 3 minus square root of 5 times 10. Now 10 splits up into 2 and 5. So 5 would have an exit buddy. And we're left with a 2 on the inside. And this first one's just going to be square root of 15. There's no simplifying happening there. But on the second one, the second term here, we have 5 square roots of 2. There we go. And that's all that we can do on that one. Let's go ahead and turn the page and see the next set. This is where it gets really tricky. Okay, you know me. I like to make things difficult for you. And, you know, it's what I do. And Mom always said, do what you do well. And so that's what I'm doing for you. If you remember in the polynomial days when we were multiplying polynomials, we had to do that FOIL thing. That's what we're going to do here. First times first. 2 square root of 2 times square root of 2. That's going to be 2 square root 2 times 2. I found that on this, it definitely helps to write out all the steps because then you don't get lost. Now I'll do the outsides. So that's going to be a negative 2 square root of 2 times 3. Okay. And on the insides, I'm going to have a plus square root of 3 times 2. And then the last, I'll have the square root of 3 times square root of 3. This one's a negative, so we're going to get a negative 3 there. So I kind of simplified that one out. Hopefully that didn't throw you for a loop. I'm just trying to make it to where I have to write a little bit less. Okay. Square root of 2 times 2, that's just going to be a 2. So 2 times the 2 that comes out of here is 4. And then I have minus 2 root 6 plus a 1 root 6 minus 3. And now what we can do is we can simplify, combine our like radicands and combine our like whole numbers on the outsides. So 4 minus 3, that's going to give us 1. And 2 square roots of 6 plus 1, negative 2 square roots of 6 plus a 1 square root of 6 is going to be a minus 1 square root of 6. That's my final answer there. I know it's a lot of work, and you can do it though. For the next one, it says squared. Now, if you remember what that squared means, is it's really that thing times itself. Okay, so I just kind of write over that squared and rewrite that whole expression to save myself a little bit of room. So that's going to be 3 times 3, which is 9. 3 times 5 root 5, which is just going to be 15 root 5. Down here I have the same thing, 15 root 5. And then the last, that's always kind of the tricky part, but it's going to be a plus. 5 times 5 is 25, square root of 25. And let's simplify what we have. So I have 9, 15 and 15 will give me 30 roots of 5. And 25 times the square root of 25, square root of 25 is 5. And 25 times 5 is 125. Okay. Now I just need to simplify the like numbers on the outside. Okay, I can just add those up and give myself 134 plus 30 root 5. Final answer. Bingo. And let's look at the last one of this row. Just another one of those problems. And if you notice anything, I have the same thing but different signs. Okay, so let's see what that gives me. 5 times 5, 25. 5 times negative 2, negative 10. That has a square root of 7 on it. 2 times 5 is going to be a plus 10, square root of 7. And 2 times negative 2 is negative 4, square root of 7 times 7. Okay, that's just going to simplify out here in a second, but I have 25, negative 10 square roots of 7 plus 10 square roots of 7. Those cancel each other out. And then negative 4 times 7, because 1 7 will come out of there. But negative 4 times 7 is minus 28. And so I'm left with just a measly negative 3. So not too bad. Okay, let's go ahead and pause the video, and I want you to try the next 3. Welcome back. Hopefully you had a chance to get those done. And let's see how you did. For the first one, pretty simple. I'm just going to multiply square roots by square roots. It should give you negative 3 square root of 90, okay, which would simplify to negative 9 square roots of 10. I'm skipping a few steps there just to speed things up a little bit. All right, for the next one, we're going to be distributing here, and I should get 5 square roots of 6 minus 5 square roots of 20, which would simplify to give me 5 root 6 minus 10 root 5. If you need help figuring out how I made those jumps, feel free to ask me. I'm always available, okay? And I'm always welcome to helping you. But on this one, you should have the FOIL process, and nothing really combines after you do that. So you should get 35 plus 20 root 7 plus 7 root 2 and plus 4 root 14. So nothing simplifies, nothing combines. That's just kind of an ugly answer, but it's still better than having a bunch of parentheses. Okay, let's talk really quick about dividing rationals, or not rationals, radicals. Okay, we really can't have an answer, so we cannot have any radicals in the denominator. So we cannot have radicals in the denominator. Otherwise, we're okay with just leaving it as a fraction, okay? But what we're going to do is what's called rationalize the denominator. Okay, we're going to rationalize the denominator, because if you remember way back when to Unit 1, I think even Section 1, we know that square roots of non-perfect squares are irrational numbers, and we want to turn the entire denominator into a rational number. And what we're going to do is we're going to use the idea that the square root of any number times that same square root of that same number is just going to give us that number. And that's kind of tough to hear, but let's see what it looks like. I want to multiply this by square root of 5 over square root of 5. Now, if you just look at this thing in blue, that would equal 1, right? Because anything over itself equals 1. So I can multiply any number by 1 and it stays the same. All right, it's just a different form. It's kind of like when you reduced fractions. It's the same idea. So here we're going to get 4 times square root of 5, which is just 4 root 5. And then on the bottom, I'm going to kind of put my work over here in a different color. I get 4 square root of 5 times 5. 5 times 5 is, or square root of 5 times 5 is just 5. So I'm going to be left with 4 times 5 on the bottom, which is 20. So all I get here is I get I get the 4 root 5 over 20. And then I can simplify that because 20 and 4 are multiples of each other. Okay? I'm not going to be messing with the square root of 5 because that's its own separate monster. You know, that's kind of off to the side. But 4 divided by 20 will simplify to give me 1/5. So 1/5, and that's actually 1 root 5 over 5. And if you wanted to, you could write it as square root of 5 over 5, because we don't need to write that we're multiplying by 1. Either one of these would be acceptable answers. Okay, either one of those two would totally work. I'd accept it, but make sure that you do reduce it if you can. Let's look at the next one. We're going to do the same thing. So I want to get rid of the square root of 10 on the bottom. So I'll multiply it by square root of 10 on the top and the bottom. Whatever I do to the bottom, I have to do to the top. Same thing with reducing fractions. Okay. Now what we actually do here is that we distribute this square root of 10 into the top. Excuse me. So that'll be 4 root 10 plus 3 square root of 5 times 10. I'm going to leave it like that. I'm not going to write it as square root of 50 because I just think it's easier. And then you can make the jump to say that square root of 10 times square root of 10 just equals 10, and say that we have that that's over 3 times 10. Okay? And so let's go ahead and simplify this. If I look at this square root, this would simplify, 10 would simplify to 2 and 5, giving me 2 5s in there. So that 5 has an exit buddy. And so that's going to come out and be multiplied by that 3. But let's rewrite what we have. 4 root 10. 3 times 5 is 15. So plus 15. And then what's left over is just the 2. All over 30. Okay. I don't want to reduce that. All right. Anytime you have 2 things on the top, I would just say avoid reducing it. Avoid trying to, because it is difficult. It can reduce a little bit, but it's not really worth it. Okay. Let's look at the last one here, and then you can try a couple. Now, what I'm going to use on this one, because it is weird, I do have a radical in the denominator. I want to get rid of that. But if I just multiply this by square root of 2 over square root of 2, I'm still going to have that square root of 2 tagged onto that negative 4 out front. So I'm going to use the idea that we got from here. Okay, if you look at this problem, and this is really why we did this problem, when I have this difference of squares, look, because that's really what it is, I come out with just a single number, and that's going to be every single time. You're going to not have any square root signs. You're just going to be left with a number. So we're going to use that idea. So what I want to multiply this by is this thing with a different sign in the middle. So I'm going to multiply it by negative 4 plus square root of 2. I'm going to do that on the top and bottom. Okay? Now let's look at what we get. Let's start with the top. So I'm going to distribute the square root of 2. So square root of 2 times negative 4 is negative 4 square root 2. Square root of 2 times square root of 2 is just 2. And then on the bottom, this is where it gets really ugly. You got a FOIL. Okay? Negative 4 times negative 4 is 16. Negative 4 times square root of 2 is negative 4 root 2. Negative square root of 2 times negative 4 is going to be a plus square root of 2. Sorry, plus 4 square root 2. Continue my fraction bar a little bit because the bottom gets a little ugly, but it will simplify down if we've done it right. And then negative square root of 2 times positive square root of 2 will just be a negative 2. Now, like what happened in the upper problem up there, the middle terms cancel each other out, and I'm really just left with 16 minus 2, which is 14. Oh, I don't know why I wrote it there. Negative 4 square root of 2 plus 2 all over 14. So keep in mind that does reduce, but it's not really worth it. Excuse me. It doesn't make life that much better in that case. But if you found a way and you looked up how to reduce that, you definitely could. What I want you to do now is pause the video, try these last two. Okay, welcome back. Hopefully what you did is just multiply this by square root of 2 over square root of 2 and got, that's going to be 3 root 6 over 2. Done deal. That one was easy. This one's hard. There you go. Hopefully you multiply this one by 5 minus root 2 on the top and bottom. And then you distribute it. So you get 10 minus 2 root 2 over, here's the ugly part, 5 times 5 is 25. 5 times negative root 2 is negative 5 root 2. And then we get plus root 2 times 5, which is plus 5 root 2. And then square root of 2 times negative square root of 2 is negative 2. So that's going to give us 10 minus 2 root 2. Those cancel like they should. And I'm just left with 25 minus 2, which is 23. All right. Tough section, I know. If you need any help, feel free to ask me. That's what class is for. And good luck on the practice application and mastery challenge. We'll see you guys next time. So we're still looking for the top Abbott and Costello clip. You might know what it is already, but we're going to live the ride anyways. It's pretty hilarious. Number 3 was horse race. Number 2, 7 into 28. This is a sort of math clip. It almost made it into the math fails lineup, but I knew it was funny enough that we had to put it here. So deal with the notation difference. This is all about division, or one part of it's about division, and they do write it a little bit differently. But if you can get by the strange writing of it, it'll make a lot of sense and it'll be really funny. So enjoy.
Mr. Landlord.
Yeah?
What are you smoking, an army blanket?
Never mind about that. You owe me room rent.
All right, here's $28.
$28, fine. Just a minute. You owe me 13 weeks at $7 a week, and that happens to be a lot more than $28.
Well, that comes to $28.
Did you go to school?
Yes, sir.
Do you mean to say that you can prove that 7 times 13 is 28?
Well, it's got to be. Certainly it is, because Mr. Rabbit and I, that's $28. That's what you get.
If you can prove it, I'll tell you what I'll do. I will give you the room rent for nothing.
You will?
But if you don't prove it, you owe me double the back rent. Is it a deal?
That's a deal.
Okay.
You happen to have any Crayola on there?
Crayola?
Never mind. I got it.
Oh, you have?
I got the Crayola. 7 into 28 is going to come out 13.
That's your way.
That's my way, and it's got to come out right. Now, first, I put down a 7.
Right.
Now, I'm going to divide the 7 into 28.
Yeah.
I put a 28 there.
Okay.
Isn't that cute? Now, here we go. 7 into 2. 7 will not go into 2.
It will not.
That's a very big 7 to push into that little bit of 2.
As you say it is.
We ain't going to hurt that little 2, are we?
Of course you won't.
So we take the 2, open your hand.
Yes.
And I put that 2 right there for safekeeping. But don't drop it and don't lose it. Now, 7 into 8.
Once.
I put the 1 over here, 1 over there. Now, we're going to carry the 7 because it's very big and it's getting heavy on my shoulders, and I'm going to drop the 7 under there. Now, 7 from 8
is 1.
Is 1. I put the 1 down there.
Mm-hmm.
Now it comes. Would you mind opening up your palm of your hand, please? Or would you like to use that 2? Open it up. Give me that 2. You've had it long enough. I'm going to put that 2 right there. Now, 7 into 21?
3 times.
That's right. 7 into 28, 13. Good enough?
Wait a minute. You have to prove this even better than that. You can prove it very easily by multiplication.
You mean you want me to multiply it?
No, not multiply. Multiply.
Multiply.
Multiply.
All right. Multiply it.
7 times 13 is 28. Go ahead.
Now, first, we got to put down a 13, right?
Right.
There's a 13.
Times 7.
Times 7.
Right.
7 weeks times 13, right? 7 times 3.
21.
21. 7 times 1.
7.
7. 7 and 1.
8.
And 2 to carry. 28.
Now, wait a minute. I'm still not convinced. There's one sure way of proving this. One sure way, and that's by addition.
You want me to addition it up?
I want you to put 13 7 times on that wall and then draw a line and add them up.
You want me to put down 13 7 times?
That's right.
It's got to come out right. There's 1.
1,
2,
2,
3,
3,
4,
4,
5,
5,
6,
6,
7.
Wait a minute. What's the idea of spreading them out like that?
Well, it looks like a flock of seagulls going to hit the electric poles. Now we're going to add them up, right?
All right, go ahead.
Here we go. 3, 6, 9.
Wait a minute. Let me do the adding this time.
Good. Come out right.
Well,
3, 6, and 9.
Just a minute. I will do the adding. Then there'll be no mistake.
Yeah?
All right? $28 each. All right?
Sure.
Now.
Go ahead. You had it up. Go ahead.
3, 6, 9, 12, 15, 18, 21.
22, 23, 24, 25, 26, 27, 28.